Test automation. Is it a technical issue, or should managers know something about it? Well, I believe it's very important for managers to know something about test automation, but unfortunately, what a lot of managers think they know about test automation, they actually don't. They're wrong. This is a typical manager's view of test automation. Manual testing takes too much time. The tools look great. Automation must be pretty easy. I'll save money by having fewer testers and meet my deadlines. Okay, team, here's the tool. Automate the tests. Off you go. Oh, no, of course, there's no extra resources or time. Well, what do you suppose is going to happen? 6 months later, what do you think? What went wrong? Well, obviously it must be the tools, right? Susan Windsor in this morning's presentation told a story of an organization where they bought a very expensive commercial tool. After 6 months, they'd made no progress in the automation. They bought another different tool, another expensive commercial tool. 6 months later, that one hadn't worked either, so they bought yet a third one, and they never achieved any benefit from their automation. But, of course, the tools got the blame. Maybe the testers will get the blame. The testers or the test automators haven't done a good job. Well, excuse me, Mr. or Miss Manager, do you think perhaps your attitude has anything to do with it, or your misconceptions about automation? I'm going to talk about 5 different misconceptions, and then we'll talk about what to monitor and how to get back on track if your test automation isn't quite what you want it to be. The first misconception, it's easy. Just record those manual tests. Now, first of all, what you record is actually not a test. What you record is the inputs. In fact, they are probably hard-coded inputs. And it's not a test. A test, the essence of a test is, does it do what it should? And when you're recording the inputs, you're actually not looking at what does it do what it should. You're just looking at, does it do? It's only a test if there is some expected outcome to compare it to. If you do record a test, and by the way, the recordings look brilliant when you see them demonstrated, it produces a brittle and unstructured script. Any unexpected event will derail that script. If the software changes, you then have a maintenance nightmare. A recorded test is great, and it will play back provided the software has not changed at all. But of course, if the software hasn't changed at all, you don't need to play back the test. When you do need to play it back, when the software has changed, a linear test, a recorded test, will fail, or it will take a tremendous amount of effort in order to actually maintain that test to give you something usable. What happens if you have a choice between spending the time on maintaining the tests and doing the tests manually? Any change in the software may be multiplied by the scripts many times over. What tends to happen is the manager doesn't tend to say, oh, let's just fix the automation and we'll move the release deadline because that's important long term. What tends to happen is that the automation gets abandoned in the next release just when it would have provided some value. Misconception number 2. It's the tester's job to automate the tests. In a way, it's unfortunate that we call it testing tools, because it's not necessarily the testers who should be the ones who are involved with tools directly. Test automation is not testing. Test automation is, in fact, software development. In order to be a good test automator, you need programming skills. A lot of people don't realize this now, but a lot of people still don't realize that these roles are very different. Now, some testers are quite happy learning programming skills and becoming test automators, but not every tester wants to become a developer, and not every tester would be good at it. So the automators don't necessarily need to have testing skills, although it is important they understand something of the testing process. There's also a conflict of interest. If a tester is also the automator, if one person takes on both of these roles, what happens? Do I test today or do I automate some tests? The automation would probably give us better long-term benefits, but what happens if we're under deadline pressure and we haven't got time to do the automation and to also do the manual tests that we won't have time to automate? What tends to happen is that you get pushed back into manual testing and the automation gets abandoned, again, at the point where you might have got some benefit from it. Misconception number 3, and this is one which unfortunately seems to be quite popular among higher level managers. We can reduce the number of testers once we have the tool. Now, there's only one situation in which this actually holds true. And I want to ask you, what are your testers like? What do they actually do? Are they mindless morons who just type anything that's in front of them without engaging their brain at all? Or are they intelligent investigators who can explore the software, who can find bugs, who can make sure that things don't get out to your users? If your testers really are literally mindless morons, then perhaps they can be replaced by a tool. But if your testers have brains and they use their brains, they cannot be replaced by a tool. In fact, you actually need more skills if you do test automation, not fewer skills, because you need the automation skills which are development skills. The best use of the automation is actually to free the testers from some of the mundane tasks so that they can do better test design and more exploratory testing. This means they will find more bugs. And if that's the aim of testing, then freeing them up so that they can do more of it will give you much greater benefit. This is very important. The tools do not replace testers. The tools support testers. Misconception number 4. Oh, we're agile now, so the developers will do the automation. Well, yes, certainly the developers can and should use test-driven design for unit testing. This means the first thing they do is to design some tests, then they automate those tests, and then they write the code until it passes the tests. At that point, they have the automation for those tests. It is, of course, only at unit level. By the way, it's a good idea to develop your automation in an agile way. Think about having short sprints for the automation, clear, well-defined small tasks, well-defined goals, small bits of functionality, a multidisciplinary team, and good communication with the users of the automation. So Agile is good for the unit testing, but what about system testing? I have a little picture to show you which highlights what the situation might be like. So maybe every little unit is okay, but perhaps the whole wall has got something wrong with it. So what about system testing? Now the ideal is probably to have the automation part of done for each sprint. And if you do it that way, that's good. Then you have done, if you like, with the automation being included. Sometimes that's not an ideal way to work for whatever reason, and here's an alternative way to do it, which can work very well. If we have our Sprint 1 manual testing of that release done by the testers, once that gets released into use, then Sprint 2 and the manual testing would be done on that sprint. At this point, this is where it's very important for the test automators to be involved. At this point, this is where you decide which tests you are going to automate. The test automators would normally do this in conjunction with the testers. At this point also, you have the opportunity of stepping back and saying, well, let's just think about what the best regression tests would be and select that from the tests that were run manually for this particular sprint, which is now release 1. The next sprint, we're going to be doing the manual testing on Sprint 3, and we're going to automate the tests for Release 2. But now we have the benefit of using the automation that we built in the previous sprint to run the regression tests on Release 1. And as time goes on, we still may be doing the manual testing for our final sprint and automating from the previous one, but now we get the benefit of being able to run a growing set of regression tests on the accumulation of our sprints. So we are taking an iterative approach to building the automation. Misconception number 5. Oh, it's a technical issue, so I, as a manager, don't need to be involved. Actually, management support is critical for success on any other than a very small scale. One of the things that we've been finding recently, we're currently writing a book which will be called Experiences of Test Automation. And the stories that are coming in there, people who have been successful in a large scale have had very good management support and have had very good communication. The managers take an interest in what's happening, they understand it, they support it, they provide the resources and the funding so that things can be done well. Another critical aspect is, what are the objectives for the automation? And the objectives for automation should be different to the objectives for testing. What is testing? Testing is investigating the software. The aim of testing is often to find lots of bugs, but automation does not find bugs. Automation just simply runs tests. One given test, whatever its bug-finding capability is not affected by whether that test is run manually or automated. If the bug is there and it's capable of finding it, it will find it, whether it's run by a human being or a tool. So finding bugs, particularly if you're going to be automating regression testing, having a goal of finding lots of bugs is probably going to set you up for failure, because regression tests by their nature do not find many bugs. They're tests that have run before, and they passed when they were run before. So the objectives for automation need to be tied not to testing objectives, but to things which the automation is capable of doing, related to efficiency rather than effectiveness. Another common poor objective for automation is just automate 100% of the tests. Why? Are all of the tests worth automating? Probably not. Some are better done manually, checking things by eyeballing them. Does this look pretty? Others are not run often enough to justify automating them. Others probably aren't very good tests anyway and should be thrown out in the first place. But if you only automate your existing manual tests, you're also missing a major trick, because there are things that you can find in the automation that are very difficult to find manually, particularly comparing results behind the scenes. Another aspect where managers' involvement is very important is you need to measure the costs of automation, but also measure the benefits and the return on investment. This is an area, measuring costs is generally fairly straightforward, the licensing costs, the people time, and so on. Measuring benefits for automation is not quite so easy. And measuring return on investment, I think, is quite tricky. Now, I have some experiments that I've been doing in this area, and have a spreadsheet that I would be happy to email you if you're interested. And there's some articles on my website about this as well. But it is important to measure these. Otherwise, how do you know you're doing the right thing? And the final issue to talk about here is the testware architecture and levels of abstraction. Although this is a technical idea, this is probably the most critical aspect for successful and long-lived automation, which is widely used. What happens typically when people first get a tool? Well, here's the tool. Testers, off you go. So the testers decide they need to write some tests in the tool scripting language. So the first thing they have to do is to learn the scripting language and to turn themselves into programmers. Often they don't become very good programmers, and often the scripts that are written are recorded or not much beyond that, and they're very tightly stuck to the tool. If the tests and the tool are tightly stuck together, I call this the T model because it's tight together. What tends to happen then is that these are the kind of scripts which are very costly to maintain. Can often be a maintenance nightmare. But this separation of levels, at least two levels of abstraction, are ways to get around the problems here. The first thing to separate out is the scripts and the tool-specific things need to be separated out from the testware. The testware consists of all the things that we need for the tests. Of course, there will be some things which are tool-specific, but keep those to an absolute minimum. Have the testware architecture have the things that you need for the tests, but have it be modular, have it be structured according to good programming practices. Years ago, when people were new to programming, they wrote spaghetti code. I've done it myself. But now, testers who are new to programming are writing spaghetti tests. They don't know about the development methods that have been developed over the years to get a good structure to what they're developing. And we're missing an opportunity if we don't have developers, good developers, involved in building our testware architecture according to good programming practices. So the test automators are the ones who structure this separation between the tool-specific things and the low-level scripts and the testware architecture. By the way, it's also very important to have this be independent of the tool. Your testware architecture should not be closely tied to your tools architecture, or at least it needs to have the ability to be separated. Now, the tool vendors will probably love it if you adopt their architecture, but that means you're sort of tied into their tool forever. But what you want to do is you want to have your tests so that even if you had to change your tool, you could preserve the investment you've made in your testware. Now, why would you want to change a tool if you're happy with the one you have now? A number of reasons. Perhaps the tool has moved in a different direction than your applications, and it's no longer the most appropriate tool. Perhaps a new release of the tool has come along, and this involves making a lot of changes to your testware architecture. Or perhaps the tool that goes out of business, the tool disappears, the tool vendor is taken over, and that tool is no longer supported. There are a number of reasons why it's a good idea to separate yourself from the specific aspects of the tool. And basically, it's good design principles. The other level of separation is to separate out the tests from the testware architecture. The tests should be written by testers in a language which is understandable to them, relative to their domain. So the testers should be able to write the tests using high-level keywords in a domain-specific test language, not in low-level scripts. If a tester is in the financial industry, then their domain is financial, and their keywords will be related to financial things. If they're in communications, then it would be related to communications. But the testers should be able to write and run automated tests without having any knowledge of the tool itself, the detailed scripting. They should just be able to test. They should be able to drive the test automation. Of course, they do need support from the test automators in order to implement the keywords and to help with technical issues. So if you separate out the bottom level, it means your maintenance will be minimized because you're using good coding practices for the test code. It will be easier to change tools. Your test automation will survive more than one release of your software, and it will survive more than one tool. If you separate out this top level, it means your automation will be used by more people. Any tester can come along and write and run automated tests. It will be used more within your organization. It will be more widespread. Of course, it needs standards and things like that, and there are many other aspects as well. But this, I think, is the key idea, to separate out these layers of abstraction in order to be successful in test automation. And here's a way just to help you remember that. Can you drive a car? Normally, you go to a new city, you hire a car, you assume you'll be able to get in that car and drive it away, right? So can you drive any car? What about this one? It's a Model T Ford. Let me tell you a bit about how it works. There are 3 pedals on the floor. The left one, when you push it down, puts you into low gear, going forward. If you want to go into high gear, you take the parking brake off and lift your left foot up again, and that puts you into high gear. The right-hand pedal is the brake, and the middle pedal is reverse. Now, I haven't said anything about how fast the engine is going. That's controlled by a lever on the steering wheel, not to be confused with the lever on the other side, which controls the spark plug advance. So how do you think you'd get on driving this car? Perhaps a little bit more difficult than your standard one? Precisely. It doesn't have a standard interface. No, it's not the case that any driver can come and drive that car. The other thing with the Model T is that if you were going to take it on a journey, you'd better be a pretty good mechanic, handy with a spanner, because if anything went wrong, you would have to repair it yourself. So we want any driver to be able to drive, so we have standards and we have an interface which is easy to use for the driver. That's that top level of separation. And we also want to separate out the mechanics at the bottom level from the testware itself as well, so that our testers don't have to be mechanics in order to use test automation. Okay, we've looked at a number of misconceptions, and I'm sorry to tell you, but they're all wrong. So what we want to look at now is, if you are having problems with your automation, what should you monitor and how would you get back on track? First of all, you need to look at benefits and costs. Your benefits should be increasing. How are you measuring benefits? Perhaps the number of tests that are run, perhaps the coverage of the software. You could perhaps use a measure like EMTE, which stands for Equivalent Manual Test Effort. If a test takes 4 hours to run manually, and if you run that test in 10 minutes automatically, every time you run that test for 10 minutes, you accumulate 4 hours of equivalent manual test effort. Now, of course, this is something which could be misused, as with all metrics, and I've had something on my blog about that. But you need some way of measuring the benefit of automation. Costs tend to become visible by themselves, but benefits, you need to show what they are. But what are the costs of automation? Well, there's the build costs, the initial cost of developing your testware architecture, as well, of course, of the costs of the tool itself if you're not using free or open source. There's the maintenance time and effort. That can be very significant. And there's one other aspect I just want to say a couple of things about, which is often overlooked for automation, and that's failure analysis time. If you're testing manually, you go along and you say, oh, that looks okay, that looks okay. Oh, that's not right. I found a bug. Now, you're about to write up a bug report, and you know exactly what's just happened, what's happened in the last 10 minutes, where you were in the application. You have the context in your head. What happens when an automated tool reports a bug? You get a red bar. Test 42 failed. Oh, what was test 42 doing anyway? You have to go and investigate. You have to replay it and find out where it went wrong. You have to spend the time to build the context, and that takes time. Another example, supposing you have a very minor bug, which doesn't really matter too much. It's not going to be fixed in this release anyway. But all of your automated tests, when they run, trip over this bug. All your bars turn red, and you have to look at the first one. Oh, it's that little trivial bug that's not going to be fixed. The second one, oh, it's that same bug. The third one, oh, yeah, I know about that one already. Every single one that fails you have to look at, and it gets very frustrating, and it eats time. Now, there are ways to get around it, but I haven't got time to talk about that now. So what should you look for informally to get your test automation back on track? Can your non-technical testers write and run automated tests? If so, then you have that top level of separation. How much effort would it take to change to another tool? Go and ask your test automation team that question. If they all turn pale, it may be that they haven't separated out that bottom level sufficiently well. How can you get back on track if you're not achieving what you were hoped for with automation? Perhaps you should revisit or revise your automation objectives. Perhaps you're heading down the wrong track because you were pointed in the wrong direction. Look at the automation testware, your framework, the architecture. Don't be afraid to take the time to refactor it if it's not giving you the benefits that you need now. So, are you suffering from any of these misconceptions? If so, please disillusion yourself. Understand as a manager and support test automation. Do realize that it takes time and effort to grow good automation. If you want return on investment from automation, you have to make some investment. If your investment is zero, your return will be zero. Understand that and support it, but do keep an eye on it as well. Monitor the costs and the benefits and the return on investment. And one last piece of advice, buy our new book when it comes out later next year, 2011, Experiences of Software Test Automation. I'll put up a final slide which has got some free stuff that you can download from my website. But thank you very much for listening. I'll hand you back to.
Thank you very much, Dorothy. And I see that we've got a couple of questions coming in there. So we'll just take the first one there. It's from Richard Forjo. And Dorothy, Richard wants to know, what are some methods of measuring benefits of automation and any techniques used?
Thanks, Richard. Ways of measuring benefits, I mentioned equivalent manual test effort already. That's one way to measure the benefits of automation. Another one is to see how many times a test can be run, because it may be that manually you can run a test perhaps just once every 2 days if it's a very long test. But if that test is automated, it might be able to run every night out of hours, so that the number of times tests can be run, how quickly the test can be run, how much manual effort it takes in order with the testing as a whole, including sort of kicking off the automated tests and so on. Again, if you'd like to get this return on investment spreadsheet, I have some other ideas in that, including the ones I've just mentioned. And I'm very happy to hear from people who have found ways of measuring return on investment from automation so that I can improve the spreadsheet and share it with other people as well. Thanks for the question.
Thank you, Dorothy. And we have another question from Michelle Craig, who's asking, Dorothy, you mentioned automators automate best tests. What do you define by best tests? Which tests should be automated according to you? And how do you know which tests are best for future releases?
That's a good question. There are some tests that when you look at them, you say, yes, every time the software changes, I want to check that. And those would be tests that you maybe put in a smoke test, a high-level regression test. Sometimes it can be a bit difficult, and you have to make some kind of a value judgment on which are the best tests. You don't necessarily have to say, these are the set of tests that I'm going to run in as my automated set. It's a good idea to have sort of layers and groups and separate out some of the tests so that you don't need to run them all at once. You might have, say, a set of tests that you run as a regression every time anything changes. You might have some other tests that you say, well, sometimes we're going to run these tests because they go into more depth, and other times we'll run a different set of tests. Maybe you have the bug fix tests and so on. So deciding which are the best tests, think about what value that test gives you. Think about, does this test overlap with any other tests? And just try to get a representative set of tests. There's probably a lot more to be said about that, but I think in the time frame that hopefully that's been of some help. Thank you.
Thanks, Dorothy. We've also got a question here from Gianni, who wants to know, do you have any experience with Ruby and our spec for test automation? He's interested to know pros and cons.
Yes, I'm sorry, but I don't talk about any specific tools, because if I talked about some specific tools, then I would be not talking about other tools. I talk about more of the general issues of test automation. I believe there are lots of stuff available on the web where you can look at user groups, and there's a free test conference and lots of information about open source tools and so on the web. So I'm afraid I can't really answer that question, sorry.
Thank you very much. We've also had a comment here from Donald Stewart, Dorothy, who just wanted to pass on that it's an excellent webinar. So thank you for that again. We don't seem to have any further questions right now. So thank you very much, Dorothy, for an enlightening presentation, and to all of you for attending. Just to remind you all that the webinar has been recorded and it will be available on our EuroSTAR website shortly. So for this and details of our forthcoming webinars, please visit www.eurostarconferences.com. The webinar is now ended. Thank you all very much.